Now we'll demonstrate a new kind of problem. In these problems, we will be given a probability and be asked to find an x value. Now it's kind of the opposite of before. They'd say for the foot length, what's the probability that someone would have a foot length of greater than 13 inches? Well, now they're saying, well, what kind of foot length, or yeah, how large would someone's foot have to be for the probability of their foot to be that length to be 12% or something like that? That's kind of crazy. It's pretty much asking the opposite of what we've been asking before. You were given an x value, and then you find the probability. Now they give you a probability, you got to find an x value. Oh yeah. The previous problems we worked all followed the same general form. Given values of a quantitative variable x with a normal probability distribution, we found an associated probability. Two basic steps in the solution process were as follows. Okay, we first convert the x value to a z-score. Then we use the applet to find the associated probability. The next example is a different type of problem. Given a probability, we will find the associated value of x. The solution process will go in reverse order. We'll first use an applet to convert statements about probabilities to statements about z-scores. Then we will convert the z-scores to x values. So just totally undoing the process we learned on the previous page. These types of problems are informally called work backwards problems. I like that. Sometimes you see that in algebra too. You learn one thing, how to do something, and then you want to learn how to undo it. We will use a new applet for these types of problems. The new applet requires us to enter a probability and then gives us the associated z-score. This is backwards from the applet we worked with previously, where we entered a z-score to find the probability. We will use the applet in the next example. Oh, here's a work backwards to find x example. Okay, I'm gonna scroll down here and then we'll start thinking about the example. Oops, so it says foot length in inches of a randomly chosen adult male has a normal, oh my God, I'm so tired of this problem. Normal probability distribution with a mean of 11 and a standard deviation of 1.5. I guess if we introduce a new example, it'd be just not only does the new process of calculating this work backwards thing confuse us, but also these new numbers are confusing us. So I guess it's good that they're using the same example. I'm very familiar with the 11 and the 1.5, so I'm not going to get confused by that. So x is the foot length in inches. First, suppose that an extra large sock is designed to fit the largest 30% of men's feet. That's an interesting question. What is the smallest foot length that fits in the extra large sock? Okay, step one, use the applet to convert the probability to a statement about z-scores. We want to mark off the largest 30% of the distribution. So the probability to the right of the z-score is 30%. This means 70% of the area is to the left of the z-score. Enter this into the applet. So we're going to drag, okay, let's see, 30, 0.3, wait. So I'm finding that when I type in, I think this is asking for a z-score, and then it'll give me a probability, but I don't want to give it a z-score. I want to give it a probability. So I'm going to move this orange line until I see a 0.7 exactly. Okay, there it is. Now I see 0.7. So try that. I see that here. And then it gives me the z-score down here. It's about 0.5304, or if you round it, maybe 0.53. Okay. Right? Yeah. Yeah, okay. Here's a snapshot of our results. Okay. Clear. That's a snapshot of our results. Okay. Now we need to convert the z-score to a foot length. Before we calculate the length, note that the z-score is about 0.5, so the x value will be about 0.5 standard deviations above the mean. Yeah, I guess technically it was 0.53, but we'll just round it to 0.5. So I'm going to say, and think this is the top 30% foot length, so it's going to be plus. You're going to have a standard deviation, or it's going to be bigger than the standard deviation, so we're adding it. X is, I guess it's almost like, maybe no, the formula before was, z is equal to x minus mu over sigma. But what if we solve that for x? So I know if you don't like algebra, then don't worry about it. But this is where they're getting this this work. Solve for x, because now I know z and I want to find x. So I'm going to try to get x by itself. I'll multiply both sides by sigma. That'll basically move the sigma to the left side, and then I'll add mu to both sides to get x by itself. Plus mu plus mu. I think that's where they're getting this. Our x will be, now that he's all by himself, it'll be this, mu plus z times the standard deviation. And the z that we got was 0.5 if we round it, and the standard deviation is 1.5, mu is 11. So that should be our x value. Now, finally, we got it. 11.75 inches. If I, say what's 0.5 times 1.5 and then add 11 to that. Okay. So finally, all that in conclusion, a foot length of about 11.75 inches is the shortest foot that an extra large sock will fit. What is the first quartile mark for the men's foot lengths? Oh my gosh, really? No, it's not that bad. Okay. I'm just messing around. So the first quartile, that means we're on the left side, should be the left quarter of this graph. Use the applet to convert this probability into a statement about z-scores. The first quarter would be the first 25% of the distribution. So I'm just going to drag that orange line until I see 25% on the left side. Let's see. There you go. That's about right. So the z-score should be here. Oh, I didn't circle it. Sorry. Negative 0.6870. So about negative 0.69 or about negative 0.7, depending where they want us to round. Okay, so I'm going to keep that in mind. Now let's scroll down a little bit and see what they got here. So this is a snapshot of it. Yeah, they said just basically 0.67 or 0.68. And we'll do the same calculation as before. Now the z-score, like we said, the z-score formula was x minus mu over sigma. But if we were to solve that for x, it would be x is mu plus z times sigma, or sigma times z. Doesn't really matter what order these two are in. Oh, it's a minus this time. I'm sorry, because we are on the left side of the mean, so I'm trying to have a minus. I'm trying to be to the left of the mean. Sorry about that. Subtraction this time. You got to keep track of that. Don't be like me and forget. And you get 9.995 inches, so about 10 inches. In conclusion, the first quartile mark is 9.995 inches, so about 25% of the men's feet are shorter than 10 inches. So interesting. We still use the applet, but instead of giving them a z-score, instead of giving them an x value and they give us a z-score, now we have to kind of work backwards and move the little orange thing so that since we know the probability, they'll give us a z-score. Okay, in the preceding example, specifically in step 2, we found the x values by reasoning about the meaning of the z-scores. We can also develop a formula for this process. Okay, we did that above. Sorry, I kind of jumped the gun. Recall the definition of z-score. In words, the z-score of an x value is the number of standard deviations x is away from the mean. As a formula, this is this guy. And this is just kind of leading up to it. They solve for x. This gives us a formula for finding x from z. You can use this formula in step 2 of a work backwards problem.